All right, so this is video 3.6, video number 4. We're going to prove x sub n equals n squared over n squared plus 1 for n equals 1, 2, and so on is a Cauchy sequence. So we start off with the proof that we have x sub n is a Cauchy sequence if for all epsilon greater than 0 there exists an n that is an element within the positive integers. Choose n equals to some number. We don't know what that is, so we have to work scratch paper out and figure out what n is, and then we can go back and do our proof. So we've got some scratch work to do on this, where all n and m are elements of the natural number set, which implies x sub n minus x sub m is our elements are less than epsilon. Okay, so we start with x sub n minus x sub m is less than epsilon. And so we look here, and x sub n is n squared over n squared plus 1. So this will be n squared over n squared plus 1 minus, and then x sub m, we're going to put m where n is. So that'll be m squared over m squared plus 1, m squared over m squared plus 1, and that's all less than epsilon. So we need a common denominator. Since we need an m squared plus 1, we're going to multiply m squared plus 1 over m squared plus 1. And here we need an n squared plus 1, so we're going to multiply n squared plus 1 over n squared plus 1. Put parentheses around all that. Okay, so now we're going to distribute the n squared, and so this will be n squared m squared plus n squared times 1 is just n squared minus, and then we're going to distribute the m squared, so that'll be n squared m squared, and so negative m squared times 1, it will be a minus m squared, and all that is above m squared plus 1 times n squared plus 1, because we have a common denominator now. Okay, so that equals to what we did up there. Well, the n squared m squares are opposites, so they go to 0. They cancel out. So we end up with n squared minus m squared over m squared plus 1 times n squared plus 1, or if you had n squared plus 1 times m squared plus 1, that really doesn't matter. Multiplication is commutative. Okay, so from here we can say that we can split that to where this is n squared over m squared plus 1 times n squared plus 1, and then plus, and then we make this a negative m squared over the same common denominator, m squared plus 1 times n squared plus 1. Okay, so from here we can split it using the triangle inequality theorem, where we had a magnitude of vector A plus the magnitude of vector b is equal to, and then here we have a plus, magnitude of a plus b. So the magnitude of a plus b is, this side is going to be less than the sum of a, magnitude of a plus magnitude of b. So this one side is less than the other two, the sum of the other two sides. So this part here, that would be the a plus b part. So we can say that this would be less than magnitude of n squared over m squared plus 1 times n squared plus 1 plus a negative m squared, absolute value of negative m squared over m squared plus 1 times n squared plus 1. Okay. So the absolute value makes this, doesn't matter if it's negative or positive, the absolute value is going to make it positive anyway, so the negative goes away. And since n and m have to be positive, right, since n and m are elements of the natural numbers, they're going to be positive. So we can go ahead and drop the absolute value. So that'll be n squared over m squared plus 1 times n squared plus 1 plus m squared over n squared plus 1, or n or m really doesn't matter, it's multiplication commutative anyways, n squared plus 1, m squared plus 1. Okay, so now let's do some analysis here, and this is kind of, we've done this before. So since n squared over m squared plus 1 times n squared plus 1 is less than n squared over m squared plus 1 times just n squared. Why? Because the larger the denominator, right, the smaller the fraction. So this is n squared plus 1, this is just n squared. So we can say that this is smaller than that. So we can say the same thing with the m squareds. M squared over m squared plus 1 times n squared plus 1. That's going to be less than m squared over, now we're just going to have m squared instead of m squared plus 1 times n squared plus 1. So this denominator is larger, so it's, the fraction is going to be smaller. Well, why do we want to do that? Because we're trying to simplify. We're simplifying this expression. So now we can go from this n squared over m squared plus 1, n squared plus 1 to just this expression is going to be less than n squared over n squared times m squared plus 1. Okay, so this expression is larger, this expression is smaller than this, and this expression is going to be smaller, this m squared is going to be smaller than m squared over m squared plus 1 plus m squared over m squared times n squared plus 1. Okay, so why do we want to do that? because we were trying to simplify. So the n squareds can cancel, and that becomes 1 on the numerator. The m squareds can cancel, and we get 1 in the numerator there. So that's going to be 1 over m squared plus 1 plus 1 over n squared plus 1. And so we can do some further analysis here, and that since 1 over m squared plus 1 is less than 1 over m squared, because this fraction is going to be small, the denominator is larger, so the fraction is going to be smaller. And we can say that 1 over n squared plus 1 is less than 1 over n squared. So we're simplifying this even further. Okay, so from here we can say that this expression is less than 1 over n squared plus 1 over n squared. All right. Now, we want so we said before that x sub n minus x sub m is less than epsilon. So n squared over n squared plus 1 minus m squared over m squared plus 1 is less than epsilon. So we can say that 1 over n squared is going to be less than epsilon over 2, since n squared over n squared plus 1 minus m squared over m squared plus 1, or you could say n squared over n squared plus 1 plus a negative m squared over n plus 1 is less than epsilon. So this could be considered as less than epsilon over 2, and this could be considered as less than epsilon over 2. And so from here we can apply the reciprocal and switch that inequality sign. So this becomes n squared is greater than 2 over epsilon. And then we can apply the square root, and the square and square root cancel each other out, their inverses, and we get n is greater than plus or minus the square root of 2 over epsilon. But since we said that, since we defined that n and m are natural numbers, their natural numbers start at 1, right? And instead of natural numbers, so there's 1, 2, 3, and so they're larger than 0. So therefore we can drop the plus or minus. So n is greater than 2 over epsilon, and we could do the same thing with 1 over m squared is less than epsilon over 2, and apply the reciprocal. So if we, we can multiply m squared and then multiply 2 and then divide epsilon, or we could just apply the reciprocal and switch that inequality sign, so that's 2 over epsilon. So if you did cross multiplication, you should get the same thing. Okay, so now if we apply the square root, drop the plus or minus, we get m is greater than 2 over the square root of 2 over epsilon. Okay, since both of these, since we identified both n and m are, so we need to identify that. So n and m, n is greater than n, and m is greater than n. So since n and m are greater than n, then we can say that since n is greater than n, and m is greater than n, then we can say that n is greater than, uppercase N is greater than the square root of 2 over epsilon. So now we've defined our n, and we can go back and write our proof. So now our formal proof, we can write our formal proof now. So basically we're just taking all this and rewriting it. We can say formal proof, where we want to prove x of n is equal to n squared over n squared plus 1 for n equal 1, 2, and on so far and so on, is a Cauchy sequence. So we let the set of our sequence is a Cauchy sequence if for all epsilon greater than 0 there exists an n that is part of the set of positive integers, and we choose n to be greater than, we said, square root of 2 over epsilon. Where we have all n and m are elements of the set of natural numbers, and we also we know that n is greater than lowercase n is greater than uppercase n, and lowercase m is greater than uppercase n. And this implies that x sub n, absolute value of x of n minus x sub m, is less than epsilon. Okay, so from here, now we just go back through the steps again, and we go ahead and substitute in our n squared over n squared plus 1 minus m squared over m squared plus 1, and that's less than epsilon. And so we already know that we're going to have m squared over m squared, right? So this will be m squared plus 1 over m squared plus 1 times n squared over n squared plus 1, so that we can get a common denominator, minus m squared over m squared plus 1 times n squared plus 1 over n squared plus 1. Okay, and so we get m squared n squared plus n squared minus m squared n squared minus m squared all over m squared plus 1 times n squared plus 1. That's equal. And so we already know that the m squared, n squareds, excuse me, they cancel out, they go to 0. So we get n squared over m squared plus 1, n squared plus 1, plus a negative m squared over n squared plus 1, m squared plus 1. Okay, and then through the triangle inequality, we know that this expression will be less than n squared over m squared plus 1, n squared plus 1, plus, and then because this is an absolute value of a negative, m squared over n squared plus 1, m squared plus 1. Because this is an absolute value, that negative goes away. And we know that this n squared plus 1, this expression is less than n squared over n squared times m squared plus 1 plus m squared over, and then the m squared plus 1 just becomes m squared, because this is less than this, n squared plus 1. And so the m squares cancel, excuse me, and that goes to 1. N squares, they cancel, that goes to 1. So we get here, and so that's going to equal to 1 over m squared plus 1 plus 1 over n squared plus 1. Excuse me. So we know that 1 over n squared plus 1 is less than 1 over n squared. And the same thing with m squared. So that's going to be less than 1 over m squared. And then this will be less than 1 over n squared. Since n is greater than uppercase N and m is greater than uppercase N, we can say that this is all less than, since n is greater than m, then the denominator is larger, so that'll make this smaller. That'll make this less than 1 over n plus 1 over n. And so n, since we said that n is, we defined n is, where is it? Where did I? Okay, we said that n is the square root of 2 over epsilon. So, so this will be so this will be, since this is 1 over n, so that'll be less, so that we'll just leave this as m squared and n squared. So this becomes 1 over the square root of 2 over epsilon squared plus 1 over the square root of 2 over epsilon squared. And the reason why this works is because since m excuse me, is greater than uppercase N, and that's greater than the square root of epsilon 2 over epsilon, then we could substitute n in for, we can substitute uppercase n in for m squared and 1 over m squared and 1 over n squared. So that's why this is squared. Alright, so from here the square and the square root cancel out, so we get 1 over 2 over epsilon plus 1 over 2 over epsilon. The square and the square root cancel each other out, and then all that, we just apply the reciprocals. So this is epsilon over 2 plus epsilon over 2, and that equals to epsilon. So all of this, x to the n minus x to the m, we have proven that that is less than epsilon. And so that defines our proof, and we are finished.